This video is about reference angle. The reference angle is a positive acute angle formed between the terminal side and the x-axis. And I underline these two terms because as we move into the examples, you see how important they are. Okay, it's formed between the terminal side and the x-axis. Here are some formulae to calculate reference angle, and we call reference angle theta prime. Okay, so if the angle forms in the first quadrant, your reference angle, which is theta prime, is the angle given to you in the question. Okay, if the angle is formed in the second quadrant, your reference angle is calculated by subtracting the angle you get in the question from 180. Okay, if the angle is formed in the third quadrant, then your reference angle is the angle you get in the question minus 180 degrees. All right, and if the angle is formed in the fourth quadrant, the reference angle is found by subtracting the angle you get in the question from 360 degrees. Okay, here's some important note. All right, so if you're moving in a clockwise direction, which is this direction, then your angle is negative. Okay, if you're moving in a counterclockwise direction, which is this direction, then the angle is positive. Okay, now the x-axis in your first quadrant is always your starting point. You always start from your x-axis in the first quadrant. Okay, now if you move in this direction, come all the way back to your starting point, that is 360 degrees, or if it is given to you in terms of radian, that is 2 pi. All right, now if you move from here to here, that is 90 degrees, or pi by 2. From here in a counterclockwise direction to here, that is 180 degrees, or pi. If you move from here all the way here, that is 270 degrees, or 3 pi by 2. And as we said before, if you move from here all the way here, that is 360 degrees, or 2 pi. Okay, if you move in this direction, it's the same thing. That this would be negative pi, negative 2 pi. Okay, or that would be negative 180 or negative 360. All right, good. Let's move into some examples. So for this example, they ask us to find the reference angle. Now, if you look at it, we move in a negative direction. All right, so the angle starts here, as we said before, from the x-axis in the first quadrant, and it ends here. Because it stops here, this is what we call our terminal side. This is our terminal side. Okay, so the reference angle is formed between the terminal side and the x-axis. So this is your reference angle. All right, and because your reference angle is in the second quadrant, then your reference angle, which is theta prime, is equal to 180 degrees minus the angle you get in the question. Okay, so because we went in a negative direction, our reference angle would be this 180 is going to be negative 180 because we went in the negative direction. Okay, minus the angle that we get in the question, which is negative 230. So that is minus negative 230 degrees. Okay, so theta prime, which is our reference angle, is equal to negative 180. Negative times negative is positive 230. Okay, so negative 180 plus 230, that is 50 degrees. All right, so this would be your reference angle. So this little part here, which is your reference angle, that is 50 degrees. Okay, all right, let's look at example 2. Example 2, they gave us the angle. Whenever you're given the angle like this, you need to draw a diagram. Okay, so we need to know which quadrant this angle falls in. Now it is positive, so of course we're going counterclockwise. So if I come here, this is 180, and I come all the way around, that is 360. I need to know how much further I need to go in order to reach 510. So if I hit 510, and I subtract this movement that I already made, which is 360, I subtract 360 from it, then I know that I need to go an additional 150. 150 falls in the second quadrant. Okay, so I'm going to estimate that 150 is about here. So I need to continue until I reach my terminal side. So the angle is going to end right here. So this would be my 510. Okay, now remember that the terminal angle, the reference angle, sorry, is from the terminal side to your x-axis. Okay, so this is our reference angle. But because it is found in the second quadrant, then we know that our reference angle is equal to 180 minus the angle given to us in the question. Now this 180 will be how many movement we made, how many 180 movement we made. So this is 180 plus another 180, that is 360, plus another 180, that is 540. So that would be 540 degrees minus the angle that we got in the question, which is 510. Okay, so we minus the 510 there. So our reference angle would be 30 degrees. So this part here would be 30 degrees. Okay, all right. Let's move into another one. This question here, they gave us the diagram for it. All right. Now, I'm going to show you how to work this in terms of radian, and I'm going to show you how to work it in terms of degrees, because some students are not comfortable working in terms of radian. Okay, they prefer working in degrees. But if you work in degrees, you need to convert it back to radian. Okay, all right. So let's go. Now, this was found in this angle is in the third quadrant. So because it is in the third quadrant, our reference angle is equal to the angle given to us minus 180 degrees. Okay, but let's work this thing here first. The angle given to us, this is what? 1 pi. Well, the angle given to us is this. So this is 31 pi by 9 minus, let's see what our 180 is now. Our 180 will be represented by how many pi movement. So this is 1 pi movement, 2 pi movement, 3 pi movement. Okay, so our 180 will be represented as 3 pi. And 3 pi is 540. See, that is 3 180 movement. 180 times 3. So that is 540. 540, but since it's in terms of pi, that would be 3 pi. Okay? Now, I could write my 3 pi as 3 pi over 1. Now, I want my denominator here to be the same as this. So I multiply top and bottom by 9. Alright, so what I would have now is my reference angle, which is 31 pi by 9 minus 3 pi times 9, that is 27 pi. 1 times 9 is 9. So my reference angle here is 31 pi minus 27 pi, that is 4 pi by 9. And this would be my reference angle. So this part here, it is formed between the terminal side and the x-axis. So this is my reference angle, which would be 4 pi by 9. Now those who are not comfortable working in terms of radian, this is how you work it in terms of degrees. So in terms of degrees, our original angle was 31 pi by 9. To convert that, we multiply this thing by 180 over pi. So this pi take out that pi. 9 into itself goes 1. 9 into 180 goes 20. So 31 times 20, that would give us 620. So this angle would actually be 620 degrees. Now, this entire thing that we started with would be 620. Now, to find a reference angle, it would still be this formula here, which would be our reference angle would be the angle that we get minus 180. But our 180, the angle that we get now would be 620, right? So that would be 620 minus our 180 would be how many 180 movement we made to reach this terminal side. So we made 180 plus another 180, that is 360, plus another 180, that is 540. So it would be minus 540 degrees. Okay, so our terminal angle would be 620 minus 540, and that would be 80 degrees. Okay, but because this thing was given to us in terms of radian, we must convert this 80 degrees to radian. So it would be 80 degrees times pi over 180. Okay, and I could say this 0 take out that 0, 2 into this goes 4, 2 into 18 goes 9. So 4 times pi, that will give me 4 pi over 9. So this would be the same as what we found here, 4 pi by 9. Okay? Alright, let's look at our final example. So our final example here, again, we need to use a diagram to represent this thing. So here's the diagram. Now I need to know where this thing will fall. So first, I'm going to convert this to degrees so I know exactly where it is. So this is negative 19 pi by 18 times 180 over pi. So this pi would take out that pi. 18 to itself 1, 18 to 180 goes 10. Negative 19 times 10, that would be negative 190. Now it's negative, so we're coming in this direction. So this would be negative 180. So negative 190 is a little bit further, so it's about here. So let's say this is my angle here, okay? So that's my diagram, so my reference angle would be right here from the terminal side to the x-axis, okay? So it is in the second quadrant, so again, because it's in the second quadrant, I need to, this would be the formula. Reference angle equals 180 minus the angle that we get. We call that theta, okay? So it would be, because it comes in the negative direction, it would be negative 180 minus the angle that we get, which is negative 190. So our reference angle here would be negative 180. Negative times negative is positive, plus 180. So our reference angle would just be 10. But because it was given to us in terms of this, we must convert this 10 degrees. So it would be 10 degrees times pi over 180. So 10 into itself, 1, 10 into 180 goes 18. So this would just be pi by 18. Okay, so your reference angle here would just be pi by 18. Okay, and finally, for those who already know how to work in terms of radian, so this is in terms of degrees. Those who know how to work in terms of radian, here it is. We know that this here would be our negative 19 pi by 18. Okay, so again, since it is in the second quadrant, then our reference angle would be 180, which would be pi. So it would be 180 minus our given angle. So our reference angle would be 180, but that is pi, right? But it's going in the negative direction, so it would be negative pi minus the angle that we get, which is negative 19 pi by 18. Okay, and this would give us negative pi, negative times negative is positive, plus 19 pi by 18. And again, I could convert this thing. I could multiply top and bottom, so it would be 18 over 18 times my negative pi plus the 19 pi by 18, and that would be my reference angle here. So my reference angle would be 18 times negative pi, that would be negative 18 pi by 18 plus 19 pi by 18. So negative 18 pi plus 19 pi, that would just give us pi by 18. Okay, and this is the same thing as what we found here. Okay, I hope this thing is a little bit clearer. Have a fantastic day.